Hello friends, welcome back to Digitalk. So based on the request of many engineers on the SSL topic, okay, I am going to cover multiple terms that is related with the SSL in this topic and in a very basic and simple way so that you can understand it easily. The topics that I am going to cover is about the data encryption, symmetric and asymmetric keys, what is the flow of browser to server, okay, and the role of symmetric and asymmetric keys, the difference between SSL and TLS, and what is SSL handshake, ciphertext and cipher suits. So I will cover all these things in a very short video and with a very basic explanation, and I'm sure you will understand what exactly all these terms. Okay, specifically when we talk about the security and SSL communications in WebLogic and in other any technologies. Okay. Okay. So before that, let me give you an introduction of the Digitalk videos or the WebLogic JBoss and OHS course that has been launched on the Udemy. Okay. You can see the description and the discount coupon there on the screen, and the link of the courses are provided in the description of the video. Okay. And if any chance the coupon codes are expired, then you can write on digitalk.fww@gmail.com. We will send you the revised coupon codes. So all the courses are designed for the beginners as well as professionals. Okay, so whether you are a beginner or a working professional with a good experience, then you can subscribe for this course, and for sure you are going to get a good knowledge from all of the courses. Okay. Apart from that, if you are interested in the lab documents, so we have a 34 lab PDF documents along with a 250 plus pages WebLogic PDF handbook. Okay, the all the courses are including the step-by-step execution and screenshot and instruction and explanations of the WebLogic labs. Okay, so all the labs are designed in a way that you don't need to join any professional course or no need to take any uh, guidance from any professionals. Okay, you can go through all the labs, and this contain all the step-by-step instructions, and you can do everything by your own. Okay. So if you would like to buy all this document, then you can write to us on digitalk.fmw@gmail.com and we will send you the complete instructions. Okay, this is available on bare minimum cost. So let us begin with the discussion on, so first we will cover what is data encryption. Okay, so data encryption is a way of translating the data from plain text, which is also called unencrypted text, to the cipher text, or which is called the encrypted text. So what happens is that when we access any of the website over the internet, okay, with the help of browser, okay, specifically when we access the website on the public network, which is called the internet. Okay, so the data that has been travel, okay, from your browser till the server of the particular organization that you are accessing, the server, okay, this data need to be encrypted for the security purpose so that your data cannot be compromised. No one can steal your data in between, okay, when it is on the public network. So to avoid such kind of a things, to your data should not be compromised over the internet or public network. Okay, so we have a technology in place where whenever your data is getting transferred over the internet, it is get transferred in the form of encrypted form, which is also called, you can say, in a garbage form. Okay, once the data is reached to a server, again it is converted into the meaningful information or whatever the information that has been transferred from the browser. For example, if you access the website of any suppose any banking website, okay, so first screen you enter your username and password, right? So when you enter your username and password from a browser, that it reach to the server, or you can say it is the server of the that particular banking domain or banking institutions, right, from the public network or internet. So when your username and password is transferring to the server from the internet, okay, that username and password need to be encrypted. Okay, similarly, it's not about username and password. We do a lot of transactions, we do a lot of activities when we connect to any of the website. So to secure our financial or personal data, that data need to be encrypted. Okay, so that is called the data encryption, and the encrypted data that we convert the data in the encrypted form, that data is called ciphertext. This is one of the most common terms that we discuss when we talk about the cyber security. Okay, so the encrypted data is called the ciphertext. Okay, so to encrypt data, take a piece of information and translate it into another piece of unrecognizable information. This end product is called ciphertext. So that means whatever the data that we are taking from the browser and then we are sending it to a server over the public network, that data get converted into the encrypted form, which is called the ciphertext. Okay, to get a ciphertext, you run the information that is to be encrypted through an encryption algorithm, which is called cipher suits. So now when we say that data is converted to the ciphertext or in the encryption form, so for that you need a certain kind of algorithms, right? That can convert your plain text data into the encrypted form, right, in the ciphertext. So to convert a plain text information into the ciphertext, the technology that we use is called encrypted or encryption algorithms. Okay, so there are different kind of algorithms are exist in the market. Okay, and that is keep enhancing day by day. So with the help of encryption algorithms, which is also called the cipher suit, we change the plain text into the encrypted form. Okay, so the encrypted form of data is called the ciphertext, and the algorithms that we use for the data plain text encryption, okay, is called the encryption algorithms, or which is also called the cipher suits. Okay, so what the encryption algorithm or the cipher suits does is create a new language and hide sensitive data by transforming it into this secret code. So it is converting the plain text data into some different form of data, which is, you can also say, binary data, or you can say junk data, which is not understandable by everyone. Okay, which you can only decrypt and turn back to plain text if you know the rules or what called a key. Okay, so now if that data which is getting encrypted over the internet, and it is once it is reaching to the server, okay, so at server end this data again need to be decrypted, right? So for decryption of the data at the server end, again we need certain kind of a keys. Okay, so it's not about decryption. So when the data is getting encrypted at the browser side, okay, and when again it is getting decrypted at the server side, so both side we need a certain kind of a key, or you can say certain kind of a algorithms or certain kind of a rules, which is a key. Okay, so that key is required for the encryption and decryptions of your data. So the key represents the mathematical steps the algorithm took to convert your text into hello world into the different kind of a text. Okay, without it you can't decrypt the data, and thus it is protected from unauthorized access. So if you are converting a certain kind of a text like hello world in a certain different kind of a format which is showing on the screen, okay, so that only be decrypted with the help of the keys that is required. Okay, so if you don't have a keys, then you can't able to decrypt the data. So that means it will be protected from the unauthorized access. Okay, so when we talk about the encryption, okay, so there are two major encryption techniques that is followed. The one is the symmetric encryption, and second is the asymmetric encryption. The difference is very straightforward and very simple between the symmetric encryption and asymmetric encryption, and I will tell you how it works when we configure the SSL, and how when we access any of the website with the help of browser, then what is the role of symmetric and asymmetric encryption in that case, how it works. So now if you see in the figure, we have a plain text which is, you can say, at the client end or at the browser end. Okay, this encryption, this plain text converted into the ciphertext with the help of encryption. And for encryption, what I said, we need a certain kind of a key, right? So what mentioned there on the screen is secret key. So we have a plain text and we are converting it into the ciphertext with the help of certain keys, right? And then this ciphertext again getting decrypted at the server end and getting again converted into the plain text format with the help of a secret key, right? And now here you can see that it is saying as a same key. That means the key that is used at the browser end for the encryption of the data, and the key that is used at the server end for the decryption of the data, it is same. That means the same key is required for the encryption and decryption of the data. So when a same key is used for encryption and decryption of the data at the browser or the client and server end, it is called the symmetric encryption. Okay, so now you can see that, think of a symmetric encryption like having a single key to both lock and unlock your door. That means you have a door, so to lock and unlock your door, you will have a same single key, the same key you are using to lock and unlock the door. With symmetric encryption, the same key or password is used for both encryption and decryption. So when we talk about the communication in over the public internet in the SSL, okay, so in symmetric encryption, we will have a same key, or you can say same kind of a password, which is used for the encryption and decryption of the data. It's like having a secret code that you and your friend both know, and you use it to encode and decode message. So it is again an example that you would have a secret code that has been shared between you and your friend. Okay, and you both know what is the meaning of that particular secret code. Okay, so maybe if I will talk about that, if I'm telling that a secret code that is between me and my friend is mango. Okay, so whenever we are talking with each other, when we talk about the mango, then we have a understanding that that means it is meaning of a certain rupees INR. Okay, maybe 500 INR or maybe two or $20 or $50. So that means we are getting an agreement with a certain kind of a text. If we talk about that text, the meaning of that would be something different. Okay, so symmetric encryption is fast and efficient for encrypting large amount of data. So specifically when we talk about the use of the symmetric encryption, that if you are have a large amount of data, then for the encryption we use the symmetric keys or the symmetric encryption. Okay, so however the challenge with symmetric encryption is securely sharing the key with anyone else intercepting it. That means the only challenge you can see is if same key is used for encryption and decryption, that the same key you have to be shared between all of the client and the servers, right? So this is one of the challenges that you can say in the symmetric encryption uses. Okay, so some of the example of symmetric algorithms are AES, DES, 3DES, and RCA4. These are the some examples of the symmetric encryption. So if anywhere you are seeing that these kind of algorithms are used, that means they are using the symmetric encryption. Okay. So now if we talk about the asymmetric encryption, so this is completely in the reverse of the symmetric encryption. Okay, in screen you can see that there is a plain text. Okay, and with the help of a public key, or you can say with the help of a key, it has been changed to the ciphertext, and the server end again it is converted into the plain text with the help of a secret key. And the difference you can see here in comparison to the symmetric key is different keys. That means when we talk about the asymmetric encryption, then we need two different keys, one for the encryption and second for the decryption. In the symmetric key, we were using a single key for the encryption and decryption, but in the asymmetric key, we will have two different keys, which is called the public and private keys. Okay, if you have some idea of SSL and some idea of the public and private keys, so we have two different kind of a keys. One is called public, second is called private. Okay, so that means we have two keys. One is for the encryption and second is for the decryption. Okay, so asymmetric encryption is like having a pair of keys, one to lock and another to unlock. That means if you have a door, then you may have two keys. One is used for locking the door, but other is using for unlocking the door. In asymmetric encryption, there are two different keys, a public and a private key. So we will have two keys here. One is the public key and second is the private key. The public key is widely distributed and can be shared with anyone. So as name is also clear, it is a public key that is designed for the public, right? So this public key can be distributed anywhere. Okay, and the private key is kept secret and is only known to the owner. So that means the private key that you have, it is has to be key secret. Okay, that means at you, because the name is also says that it is a private key, that means it has to be secured privately with you, with the owner of the particular server or of the website or the organization. Okay, so if someone want to send you in encrypted message, your public key to encrypt it. Once encrypted, only your private key can decrypt it. That means if someone has to send you the information in the encryption form, that public key can be used by that entity for the encryption of the data. And then once data is received at the server end, where you have your own private key, you can convert that data, or you can say you can decrypt that data with the help of private key. Okay, so asymmetric encryption is great for securely communication with someone without needing to exchange a secret key beforehand. Okay, so that means just like in symmetric key, what we were discussing about, that you have to share the same key with all of the recipient whoever wanted to have a communication, right? But here you don't need to share your key, because there is no single key. There is a public key and a private key. So whoever want to talk to you, that you can share your public key to all. Okay, and then you can keep the private key at your end, so you don't have a certain kind of a dependency where you have to share the same key with all of the recipient. Okay, so asymmetric encryption algorithms examples are RSA, Diffie-Hellman, ECC, and DSA. These are the certain algorithms that is mostly used for the asymmetric kind of a encryption. Okay, so now this is clear. Hope you are clear about on the data encryption, ciphertext, cipher suite, and then symmetric and asymmetric encryption. Okay, so let us discuss on the SSL and TLS. So SSL and TLS, the secure socket layers and transport layer security, are both cryptographic protocol for secure communication over the network. Okay, so you know that whenever we access a secure website, we give it as a HTTPS on the browser, right? So SSL and TLS both are the protocols. Okay, SSL, when we talk about the SSL configurations, then always we say about SSL. We hardly say the TLS, okay, but that is not exactly true or not fair, okay, in fact, because both are the protocols that used for the secure communication over the network, and TLS is essentially the successor of SSL and offer better security features. So you can say TLS is the enhanced version of or successor of the SSL, which is now in use at mostly at every place, and wherever it is not, it is getting upgraded. Okay, and because this is the more secure protocol in comparison with the SSL. So TLS has undergone more rigorous security and update support strong cryptographic algorithms and provide improved handshake mechanism compared to SSL. Okay, so why we are using the TLS now, not SSL, is that because the TLS has gone through rigorous scrutiny and updates. It supports stronger cryptographic algorithms. That means strong cipher suit for the encryption of your data, which is traveling over the internet, and provide improved handshake mechanism to compare to SSL. Okay, so whatever the SSL handshake is happened between the user and the client and the server, it is more secure in comparison with the SSL. That's why TLS is getting used everywhere now. So TLS is more secure and modern than SSL, with TLS 1.3 being the latest version offering the highest level security and performance. So 1.3 of the TLS is the current highly secure version of the protocol, or you can say the communication protocol that we use over a network. Okay, so this is the history of the SSL and TLS. That the initial version of SSL was 1.2, which was not released due to security flaws. Then 2.0 was released, and then after that SSL 3.0 was released, right? But in parallel, that TLS 1.2, 1.1, and 1.2 was released, and then currently the TLS 1.3 is there in the market, which is the most secure version of the communication protocol, right? So that means if you see anywhere SSL SSL protocol is in use, that has to be used or upgraded to the TLS version, which is a 1.3 currently. Okay, and SSLLabs.com is where you can go and then search for the different website. If you would like to see like which TLS version a particular website is using, then you can search for that that website name, and then you will see the what is the TLS protocol version that is getting used. Okay, so now if we talk about the web browser to the server communication, this is specifically when we talk about we are doing the SSL configuration in WebLogic, in OHS, in web server, in any of the application server, okay, or in any of the application. If you are configuring the SSL, okay, then how the communication happened between your web server and the server when we configure the SSL. Okay, now interesting thing here is when we enable the secure communication between client and the server, that means we enable both the symmetric and asymmetric communication. So we have discussed in a symmetric communication, we need a single key between server and clients, and asymmetric, we need two different keys at the server and client, right? But when we talk about the web server to the server communication, that both are getting used. How it is, we are going to discuss in detail. So asymmetric encryption algorithm to establish a secure client session, server session. So that means whenever the first request goes from your browser to the server, the initial handshake is done happened with the help of asymmetric algorithms, and once the handshake is completed between your server and the client, the rest of the transfer of the data or exchange of the data or information between your client and server is happened with the help of symmetric encryption. So these are the two use cases in when we talk about the communication between browser and server, and this I am going to explain you in detail in the next slide. Okay, and one thing that you keep in mind, SSL certificate issued by the certificate authorities can be used for both SSL and TLS connections. That means don't get confused with the TLS, SSL and the certificates, okay, authorities and the certificate that we get. The certificates that we get from the certificate authority, it can be configured for SSL as well as for the TLS, whatever you want. The type of protocol used depend on the configuration of the server and the client. So the type of protocol is completely depend on your configuration or the kind of a SSL protocol or TLS protocol that your softwares are allowed support and then can be configured. For example, if I am saying that I am using a web server, okay, then it is my web server where I can enable the SSL or TLS. Certificate will not deal with that one. You can enable the certificate, but the certificate that you are getting, it is meant to be used for TLS, but you have the liberty, you can configure it for either SSL or for the TLS, but that need to be configured at the software level. So in modern context, TLS is the preferred protocol over SSL due to its improved security and performance. So most server and clients are configured to use TLS rather than SSL, Therefore, when you obtain an SSL-TLS certificate from a CA, it's typically intended to use with TLS connections. However, it is important to ensure that your server and client configuration support TLS and that SSL protocol disabled or deprecated for security reasons. Okay, so in a nutshell, you can say that there is no link between the certificates and the SSL and TLS. It is only the configuration of your softwares or applications where exactly we enable the SSL or TLS, but your certificates support both SSL and TLS. So now let us begin with the communication flow, how the communication work when we access any application with the help of browser which is deployed in the WebLogic server or in any of the web or application server. So first thing is that when you have a client and then you have a server, the client send the request. That means the communication start with the client, typically a web browser, send a request to the server. This request is a HTTPS request for a particular resource such as web page, image or script. Okay, so we are accessing a website. We enter the URL in the browser and that request with the help of public internet reach to the server, right? So what will happen in the second case, the server respond to the client request by sending it SSL certificate. This certificate contains the server's public key along with information about the certificate issuer, expiration date and other details. So when our session is get connected with the server from the browser, your server will send the SSL certificate to the browser along with the public key. That means that particular certificate that will be shared by the server will contain the public key as well. Okay, along with that the certificate information. So when we get the certificate from the certificate authority, it contain about the expiry of the certificate, the name of the CA certificate authority who have issued that one, right? So when it reach to the browser, okay, then your browser do the complete validations of the certificate. So the client browser verify the authenticity of the server certificate. So it's the duty of the browser who will validate if the provider of that particular certificate that has been received is a valid, trusted entity or not, certificate authority or not. If the certificate is not expired, okay, once all the validation is completed and then your browser knows that okay, this is from the trusted server or from the trusted source, then encryption setup happened. Okay, so if the certificate is valid and trusted, the client browser generate a symmetric session key, encrypt it using the server public key obtained from the certificate and send it back to the server, right? So what I said initially in the previous discussion, that we use the symmetric and asymmetric keys both in such kinds of communication, right? So initially when the browser connected with the server send a certificate to the browser with along with the public key, and once the validation is done from the browser side, okay, then with the help of the public key, your browser will generate a symmetric session along with a symmetric key. Okay, so that symmetric session will contain a symmetric key. Okay, and again that symmetric key will be decrypted, okay, with the help of public key. Okay, and then this will be shared again back to the server. Okay, and that means your browser will create a session key, okay, and then it will encrypt and share it with the server, and then the server receive the encrypted session key and decrypt it using the private key which only the server possesses. That means once that session key is received by your server, it will again decrypt that with the help of private key. Okay, so now you have a session key which is same at the browser end and at the server end. Okay, so now that means both server and the client have a same key. Okay, so once they have the same key, then the actual data transmission executed. Okay, so with this session key successfully exchanged, both the client and server now possesses the same secret key. They can use this key to encrypt and decrypt the data transmitted between them. So now both have the same key. So now they can exchange the data with each other, and that data will be encrypted and decrypted with the help of the same key that has been with the client as well as with the server. So that means once the server is sending any data to the browser, then it will use the same key for the encryption of the data. Once it is reached to the client end, it will again be decrypted with the help of same session key. Now, if you recall, what I said is in such kind of a communication, we use both asymmetric and symmetric communication. So where exactly asymmetric communication come, that means where exactly the public and private key come in picture is when initially the browser connect with the server share the SSL certificate with the browser, and then browser do the validation of the certificate, then extract the public key from the certificate, and then it generate a symmetric session along with a symmetric key, and then with the help of public key, that session key get encrypted, and then this session key shared with the server, and then again server use the private key to decrypt that session key. So this is the initial part where we have used the asymmetric encryption for exchanging the similar key between the browser and the server. And where we are using the symmetric encryption is, so once that session key is shared between the client and the server, that single key or that single session key will going to be used to encrypt and decrypt the data between the server and between server and the client. So whatever the communication or data exchange happening between your server and the client will be decrypted or encrypted with the help of same session key. Okay, so this is the way how this communication use both symmetric and asymmetric communication, right? So now I hope you are clear on the SSL handshake as well. So let me tell you, when a server sends the public key to browser, the browser create a symmetric session keys and encrypt it with the server's public key, then send it to server key. This is the conclusion of what we have discussed so far, right? Now server decrypt the encrypted symmetric session key using the asymmetric private key to get the symmetric session key. Now web server and web browser can encrypt and decrypt all transmitted data with a symmetric key session. So in a nutshell, when the session key, the same session key is shared between browser and the server, and after that when they are in agreement that okay, now we both have the same session key and now we are good to go for the data exchange, that is called the SSL handshake in the network communication. Okay, so this is all about your different techniques or terms that we use in the SSL, and I tried my best to explain in a very basic way. Hopefully it's clear to all of you. So thanks for watching this video.